This is the tutorial for Chapter 2, Section 3, Reflections. And the first type of problem they're asking us to do is to tell whether the shaded figure is a reflection of the non-shaded figure. So as we look at this first one, we see that if we take a look at a corresponding point, like for instance this point right here, I see that the corresponding point is this point here. For a figure to be reflected, it needs to be the same distance from the line of reflection. You can tell this point right here is much further from the line of reflection as this point is. So this is not a reflection. And actually this one would end up being a translation. So I'll say that this is a translation. So the figure slid down and then to the right. On this next one, we can take a look at some points. Like for instance this part right here. This part is equal distance from the line of reflection as its corresponding point, which would be right here. And we can take a look at another point, maybe like this point right here is equal distance from its corresponding point, which would be up over in this direction. So since these distances are the same for their respective corresponding points from the line of reflection, we would say yes. This is a reflection. And on this next one, we can see that we have a cylinder here, and notice how we can see this part of the circle, part of the top of the cylinder here. And then on the other side, we see the same thing, but equal distance from that line of reflection. So if I look at this point right here, it's equal distance from the line of reflection for that corresponding point on the other cylinder. So I would say yes, this is a reflection. So taking a look at the next set of directions, that asks us to draw the figure and its reflection in the x-axis. So we're reflecting about this x-axis. So here's my x-axis. So this is going to be like a mirror right here along this x-axis, right along it. And so we're just going to reflect it from one side to the other side. So let's start by plotting these points, 1, 2. And this is A. And then 3, 2. This would be B. And then 1, 4. This would be C. So connecting those points, this is the shape I've got. There's a triangle. Now reflecting it means counting the spaces from that line of reflection and going opposite of that line of reflection on the other side, that same number of spaces. So point A here is 2 spaces from that line of reflection. So I'm going to go 2 spaces on the other side. So if you count the spaces, 1, 2 to the line of reflection, 1, 2 to the other point. And so I'm going to call that A prime. And B prime would be 2 points or 2 spaces from the line of reflection. So I just go on the opposite side, 2 spaces. Now C is 4 spaces from that line of reflection. So I need to go 4 spaces on the other side. That'll be C prime. And then I can go ahead and draw the shape, another triangle. So you see how you have a mirror image of this original figure, the pre-image. Then they ask us to identify the coordinates of the image. So A prime is going to end up being the same distance over in the x direction, but this time down. So it's going to be 1, -2. And notice B prime, same thing. We see that it is the same distance over, but just down. So it's 3, -2. And then C prime, the same sort of thing. 1 space over, 4 spaces down. So notice that every time when we look and compare these points, when we go from A to A prime, the only part that changes is the y component. The x component stays the same. So let's state that. So when reflecting across the x-axis, the y value changes to the opposite sign. So it's only the y value that changes to the opposite sign. The x value stays the same. So we'll see the same thing with this one. So 3 spaces over, 1 space up, and that'll be w. And then 3 spaces over and 4 spaces up, that'll be x. And then 1 space over, 4 spaces up, that'll be y. And then 1 space over, 1 space up is z. And we'll go ahead and draw the figure. So now we're going to go ahead and reflect this across the x-axis. So this is, again, our line of reflection right down here. So I just count the spaces from the point in the pre-image to the line of reflection. And I go that same distance on the other side, so that's z prime. W is 1 space from the line of reflection, so 1 space down. Y is 4 spaces from the line of reflection, so 4 spaces down. And the last one, x, 4 spaces from the line of reflection, 4 spaces down. So there it is, a reflected rectangle. And so taking a look at these ordered pairs, though, for z, and I'll put them right underneath this time, z prime, you see you go the same space over in the x, but 1 space down, 1, negative 1. Comparing to the first one, you notice how the y value changes, x value remains the same. Looking at y, it's 1 space over, but 4 down, so it becomes 1, negative 4. And for x, x prime is going to be 3 spaces over, but 4 spaces down, so 3, negative 4. The last one, w, is going to be 3 spaces over and 1 space down. And so that's what you're going to see each time when we're crossing the x-axis, or reflecting across that x-axis. Y values change, x values stay the same. Let's take a look at the other problems. And this next one asks us to reflect across the y-axis this time. So let's go ahead and draw the figure. So 3 spaces over and 4 spaces up. That'll be J. And then 3 spaces over, 0 spaces up. That'll be K. And then we have 2 spaces over and 4 spaces up. And that will be L. So we go ahead and draw the figure. But this time, we're not reflecting down or up. We're reflecting left or right, in this case left, because again it's across the y-axis this time. So this is my line of reflection right here along the y-axis. So that's what I'm counting the spaces to. So I'll count the spaces for L. It's 2 spaces from that line of symmetry, or the line of reflection, so 2 spaces to the left of that. J, it's 3 spaces from the line of reflection, so 3 spaces on the other side. And K, 3 spaces from the line of reflection, so 3 spaces to the other side. And when I go ahead and draw the figure, I get the same exact shape, just flipped over that y-axis. So this time looking at the points, let's take a look at what J is. J now is negative 3, positive 4. And when I look at K prime is negative 3, 0. And L prime, well, that one is 2 spaces to the left and 4 spaces up, so negative 2, 4. So what I see this time is that the x value changes, the y value remains the same. So we'll say that when reflecting across the y-axis, the x value changes to its opposite sign. Well, let's take a look at the next one, see if it does the same thing. And 2, 2 is going to end up being M. 2, 3 is going to be N. And then 3, 3 is going to be P. And 4, 1 is going to end up being Q. So we draw the figure. and it's a quadrilateral four-sided figure, so let's go ahead and reflect it. And I'll just count the spaces to the y-axis again. This is the line of reflection. So M is 2 spaces from that line of reflection, 2 spaces over. N, the same thing, so N prime, and that was M prime. P is 3 spaces from the line of reflection, so 3 spaces over. And Q, well, that's 4 spaces from the line of reflection. So we go ahead and draw it, and what we have is that mirror image again. And so let's go ahead and take a look at the points. So M, that is 2 to the left and 2 up. So you can see that does the same thing. The x value changes, y value stays the same. N prime, well, that's going to be -2, 3. P prime, well, that is 3 to the left and 3 up. And Q prime is 4 to the left and 1 up. So 4 left, 1 up. So you can see it does the same thing. Y value stays the same, x value changes when we're reflecting across the y-axis. So the next one asks us, well, in this pinball game, when you perfectly reflect the ball off the wall, will the ball hit the bonus target? And there's the bonus target. So what will it do when we reflect it off the wall? Well, let's try to make a triangle to see what it does in the y direction and the x direction. So here it goes 4 spaces up and 2 spaces over. Well, if that's reflection, then it's going to do the same thing. It's going to go over 2 spaces and then up 4 spaces. That puts us right here. And so if it was a reflection, that's what it'd end up doing. It ended up going here. It went up 4 over 2 to the left. And then if I do the reflection, it's going to end up going over 2 to the right and then up 4. And that's where we'll see it. So will it hit? Nope. Looks like it just misses. No, it misses. And we could say the reflection goes 2 spaces right and 4 up. Well, those are the types of problems you're going to see on the homework. Good luck.